Welcome to Chapter 5, 5.1 Randomness, Probability, and Simulation. This section's very much so an overview of probability. You're not going to delve too much into solving things, but just knowing what it is. And we start out with defining what probability is, and that is a number between 0 and 1 that describes a proportion of times the outcome would occur in a very long series of repetitions. Now, what does that mean? Uh, I like to talk about the idea of probability with a number line. Okay, and in this number line we have 0 to 1. Okay, um, so what does 0 to 1 mean? So as we get closer to 1, the better the chance of that event happening. The closer and closer we get to 0, the less likely the event is going to happen. Now, what if we had a probability of 0? That would be like impossible, right? That event is impossible of happening. 1, what would be 1? 1 would be yes, that's definitely happening, right? It is certain it would happen. It would occur every time a trial happened. Certain it would happen. All right, so we're likely happening down here, not happening down here, and if you get 0, impossible, not happening, 1 is definitely happening. Now, a rule with probability is called law of large numbers. And what does this mean? It's a proportion of times that a particular outcome occurs, and many repetitions will approach a single number. So the more times we do an experiment, the closer it is to what the probability actually is of something happening. Okay, so the more times we experiment, the more accurate our results are going to be over the course of time. Now, for real life examples, I'm just going to talk and not actually draw them, but I guess I'll just do a brief draw. So, two examples we look at are life insurance or insurance in general, and extended warranties, which you probably heard of at one point or another. So I'll start with warranties. Why are warranties probability based? Well, what the company is doing is saying, what's the chances that you break whatever it is, right? Whether it's car, whether it's your phone, anything that you can buy a warranty for. What are the chances that you break your phone, and how often does it happen over a course of time? Because why? Because they want to make money off of you. They want to charge it less enough that you actually buy it, but also keep in mind that, hey, your phone's probably going to last a certain amount of time. So they use probability based off that. And life insurance, so the cost of life insurance is dependent on like who's buying it, right? So someone like my age who's 31 is probably going to be much cheaper than someone who is, let's say, in their 60s, right? So that's how they calculate how much monthly payment they might charge for life insurance. There are two concepts that deal with probability, but also don't deal with probability that you've probably heard of, and it's the idea of having a hot hand or a law of average. So let's talk about law of averages first. So let's say that a family has 6 straight boys born, right? But they really want a girl, right? So a family might be thinking, hey, we had 6 boys already, right? So we should have a very high likelihood of getting a girl. But really, the fact is that it's still about the same chance, right? Just because 6 boys were already born just doesn't mean that uh, things will average themselves out and the next one will be a boy. So, and then there's the idea of the hot hand. You might hear hot hand in terms of sports generally, right? If you're playing basketball and someone's made 5, 6 shots in a row, they're like, you probably feed that person the ball more, right? Because you think that they're more likely to keep making them. and you kind of take probability out of it because you're like, "Ooh, that person's on fire," right? As opposed to thinking, "Hey, that person made 6 in a row, they're due to miss," right? So you're gonna probably still keep feeding the ball. Um, Now, the one thing that they said based off studies that is a little different with hot hand is that if someone shoots 2 free throws and they miss the first one, their probability for making the second one actually goes up a little bit because it's the same shot over again, right? So they're able to fix it. What we'll be talking about a lot in this chapter and the next one are simulations. That is an imitation of chance behavior, was often carried out with random numbers. So you've done simulations, or actually already throughout the year, uh, in terms of seeing what probably of something would happen and doing it randomly, right? Uh, Not less of a probability, but more of just random assignment, right? Uh, so there are steps in performing a simulation that we should follow. First is state. Ask a question of interest about some chance process. So that might be how likely you are to make the next shot, right? Or better yet, probably would be something more like how likely are you to make um, at least 10 of 20 shots, right? In basketball. Second would be plan. Describe how to use a chance device to imitate one repetition of the process. Tell what you will record at the end of each repetition. So in this case, an example, you'd be shooting 10 free throws and then record whether a made or a miss happened. Perform many repetitions of the simulation. So as I said, the more you do something, the more accurate your information will be, right? I did a different example with regards to flipping a coin, right? And I said flip a coin 5 times. Some of you might get tails 4 times or heads 4 times, right? And we all know that it's 50-50 of one thing happening. But if you were to flip a coin many, many times, uh, we're going to get a more accurate result. And then conclude, use the results of your simulation to answer the question of interest. So look at the results and then draw a conclusion based off that information. We'll do a couple examples of doing this process in class. But I appreciate watching, and bye-bye now.